time for section 5.3, which is on graphing linear functions. Linear functions, guess what every single one of these is going to look like? A line. So basically, if you know the slope of a line, remember slope is rise over run. It's a measure of how steep a line is. And if you know at least one point on the line, then it's possible to graph the line. It's also possible to find other points on the line. So let's do some examples and you'll see what I mean. It says graph a line with a slope of 3 over 4 and it goes through the point -2, -6. Alright, what you're actually going to deal with first is not the slope because you wouldn't know where to put the slope. You're going to start with the point. So we're going to graph this point, -2, -6. That should be no problem. Start at the origin, left 2 to -2, down -6. There you go. There's our point, -2, -6. Now, it says we have to draw a line through that point. Well, there's all sorts of lines we could draw through that point, right? In any direction we want. But it has to have a slope of 3 over 4. Now, remember, what does slope mean? Like, what's the little equation for slope? The little equation for slope is rise over run. And that's exactly what we're going to do here. We're going to rise 3, we're going to run 4 from that spot right there. Okay? So I start at this point and I rise 3, 1, 2, 3. I don't put a dot yet. Now I run 4. 1, 2, 3, 4. That's my next point. So I know, remember I said up here you can find other points on the line? I found another point on the line. Another point is 2, -3. Want to find another one? Just do it again. Rise another 3 from this point, 1, 2, 3, and run another 4. 1, 2, 3, 4. There's another point. Another point on this line is 6, 0. Want to find one more point? Why not? Rise 3, 1, 2, 3, run 4. 1, 2, 3, 4. Another point is 10, 3. All the points should line up on a perfect line, and they did, so we're pretty confident we did it correctly. Let's draw a line through these points. And of course, if I just did this as my answer, I could take a mark off. Why is that? Because this line doesn't stop here. It goes forever in this direction. It goes forever in this direction. So we need to put arrows on both ends. That's it. We're done. We've graphed the line. We found a bunch of points on the line. Excellent. Let's do another one. Graph a line with a slope of -2 going through the point -5, 7. So again, we're going to start with a point. So I go -5, start at the origin, -5, and then up 7, +7. Right here. This is my point. Now we have a slope of -2, and remember what we said. It's rise, so here's rise, over run. What? There's no number there. So what do we do? Well, remember, -2 is the same as -2 over what? What can you always put any number, any whole number, or any integer over and keep it the same? Put it over 1. -2 over 1 is the same as -2. So here's our rise, just like we set up here, -2, but the run is 1. So we're going to rise -2 and we're going to run 1. Rise -2, what does that mean to rise -2? If you rise -2, it actually means to go down. So we go down 2. Now if you look at the 1, it doesn't say -1, it says +1. So we're going to run 1 to the right. There you go. There's another point. -4, 5. Let's do it again. Down 2, rise, because that's running, sorry, that's rising -2 and run 1. You could keep doing this and doing this. You don't have to. Down 2 over 1, down 2 over 1. Anyway, I think that's more than enough. So we're going to draw a line through there. Okay, and again, we better put some arrows on the end of it because this thing goes over, on and on and on forever. By the way, this had a slope of -2. Is that a negative slope right here? Yeah, it is. So I'm feeling pretty good that I did it right. This one up here had a positive slope, 3 over 4. Is that a positive slope? Yes, it is. It's a good thing to take a look at once you've done these questions, just to do a quick check about whether you might have done it wrong or not. It doesn't guarantee you did it right, but it's good to at least look. Okay, and the next thing we're going to talk about is intercepts. I think we talked about them already. Intercepts are the point at which a graph crosses the y-axis and the x-axis. So if I go back here, for example, let's look at this question here. So where does this black line here, where does it cross the x-axis? It crosses the x-axis right here, right? So that's the x-intercept right there. The x-intercept is 6, 0. Where does this one cross the y-axis? It crosses the y-axis right there. The y-intercept is, I don't know exactly, but something like negative 4.6 or negative 4.5 or 4.7, something like that. 0, comma, negative 4.7. So again, maybe I'll just write this in here. This one is 6, 0, and this one is 0, negative 4 point, I'll call it 7, negative 4.7. Okay, let's go down and look at this one. Where is the x-intercept in this case? Here's the x-intercept where it crosses the x-axis, and the y-intercept is right there. Alright, this time we have a pretty point, I guess, for the y-intercept. The y-intercept is at 0, negative 2, and the x-intercept is not a pretty point. It's something like negative 1.4, something like that, 0. Now let's compare the x-intercepts and the y-intercepts. X-intercept here is 6, 0. X-intercept here is negative 1.40. This is going to be true. This is going to be true of all x-intercepts. If it's a point on this line, this axis right here, sorry, any point on this line, it's going to have a y value of 0. So that's why the x-intercept always has a y value of 0. For the y-intercepts, if you look up here, it's 0, negative 4.7. Here it's 0, negative 2. And again, any point on this y-axis here is going to have an x value of 0. So these are important points. Let's see what I said here. I said intercepts are the points at which a graph crosses the y-axis and the x-axis. And then I wrote y-intercept and x-intercept. And what I wanted to show you here is that the x-intercept is always a number. Let's call it a. That's like some number. And then the second number in this coordinate here will be 0. If it's an x-intercept, the second number will always be 0 because you're not moving in the y direction. That would take you off of the x-axis, and we want to stay on the x-axis for an x-intercept. For the y-intercept, the first number will be 0 because you don't want to move off the y-intercept or the y-axis, right? Any number here besides 0 will take you away from this y-axis. So it has to be 0, and then some number here. Let's just call it b. All right, I think we actually already talked about that before. So, determine the intercepts of a line that has a slope of 1/2 and passes through negative 4, negative 4. It's practically the same thing we just did, except this time we're going to say what the intercepts are. So we can do this pretty quickly. The passes through negative 4, negative 4, negative 4, negative 4, and it has a slope of 1/2, so we're going to rise 1, and we're going to run 2. Rise, run. So up 1 over 2, 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 etc. They're all lining up in a straight line. I can draw a line through them, put some arrows at the end of those, and I'm finished. And the question is, what are the intercepts? So we have an intercept here, and we have an intercept here, and this is a nice question because they're both pretty points. The x-intercept, that's where it crosses the x-axis, so that's this point here, and it is 4, 0. You'll notice it always, for the x-axis, x-intercept, always has a 0 as its second number. For the y-intercept, that's in this point here, it's 0, negative 2. You'll notice it always has a 0 as its first number. Okay, good. Determine the slope and the intercepts of the following lines. So they already have the line here, and we have to find the slope and the intercepts. All right. Now, usually what they would do is they would actually show you some definite points, pretty points to use. So let's do that. I didn't do that, but let's say there's a point here, and let's say there's a point right there. And we want to find the slope. Like, I don't know, it could be other ones. It's just hard to tell which ones it goes through exactly, which pretty points. So I'm just going to say those are the pretty points. Okay, remember to get the slope of a line. First of all, slope is m, if you want to just use m, and we can use rise over run. So I'm going to start at this point, and I have to make that triangle, right? I have to rise this much, and then I have to run this much. Okay, how much is this distance? 1, 2, 3, 4, 5, 6, 7, 8, 9. How much is this distance? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Rise over run. So the slope is 9 over 10. Is it positive or negative? That's definitely a negative slope. The slope is negative 9 over 10. Intercepts. X-intercept equals Y-intercept equals. Okay, the x-intercept is right here. Oh, it's a pretty point. That's beautiful. It's 4, 0. Second number is always 0 in an x-intercept. In the y-intercept, the first number is always 0, and it's right here. I can't tell exactly, but maybe 3.7, 3.8. I'll call it 3.7. Good enough. Done. Last question. What's the slope of a line that has the following intercepts? -6, 0, and 0, 4. There's a bunch of questions like this in the homework. It's no different than what you did before. When you know the points, like you don't have a graph, you just have the points, we use change in y over change in x, or if you want, y2 minus y1 over x2 minus x1. So just pick one of the points. How about I'll start with this one. So to get the slope, I would go the y values, the difference between those is 4 take away 0, and then I subtract the x values in the same order. So I have to start with this one, 0 take away -6. So what's that equal? 4 take away 0 is 4. 0 take away -6 becomes 0 plus 6, so it's 6. So I get 4 over 6, which is the same as 2 over 3. There's my slope. By the way, we could have done it the other way, right? Instead of gone 4 take away 0, I could have gone 0 take away 4, gotten the difference between the y values that way. But if you did that, you'd have to go -6 take away 0. 0 take away 4 is -4. -6 take away 0 is -6. Two negatives make a positive, and 4 over 6 is 2 over 3. We get exactly the same answer. There you go. We're all done. All right. Have fun doing all these graphs. Remember, they should all be lines.